that. Yeah, and then it turned out he not only had he misled me directly, he'd instructed others to also lie.
No.
Yes. When I say like somebody is like the worst person I've ever worked with,
Yeah.
it's pretty bad.
Yeah.
So, but SpaceX also hadn't gotten to orbit at that time, so I was like, man. So then I asked, what is the name? Harris. Remember the guy? I'm blanking on the name.
Yeah, we brought in a CEO.
The interim.
Yeah, he ran like a manufacturing company. I mean, he seemed pretty smart. The problem that I found with Tesla was we were a startup in Silicon Valley, building a car that was really manufacturing and materials engineering, and it's really like all the talent was for, you would think there was probably talent, in Detroit or Japan. But if you took any of those guys in to run Tesla, they would run it like a car company, and then it would be destroyed.
Well, they had no idea. You can take somebody who's running a giant corporation.
You just could not take someone from a massive company culture and have them do a startup, and yet you couldn't find anyone in Silicon Valley who knew enough about making cars. And so we kind of found a middle of the road one he was an expert in manufacturing. Flextronics. That's right.
Ex-CEO of Flextronics was an investor. And he agreed to just join as interim CEO, and this is 2007.
Yeah. But I mean, Tesla was a company you tried so hard not to be CEO of.
Yes. But the thing is, this is misinterpreted. If I say that, it's misinterpreted as like I somehow don't love Tesla, which I do. It's just like trying not to go insane. With work.
Yeah, being CEO of a real startup is 80 hours a week. Being CEO of two is 160 hours a week, and there's only 169 hours or something of sleep of 168 hours a week. So, like, you just can't physically do it.
Yeah, I mean, the pain level is extreme. So, that's Anyway, I tried quite hard not to be CEO, but had to be. No choice. That or Tesla would die. So that Everhard was fired in July 2007, and he was at the time we didn't know he'd instructed other people to lie, so we thought he was just it wasn't as bad. But once he left the building, then it turned out no, he'd actually orchestrated a massive deception, which is quite bad. So, yeah. He also said he came up with the name of Tesla Motors, which is false. That was created by a guy in '95, and moreover, he knows this because we went to great length. We had to buy the trademark.
Yeah, exactly.
So he can come up with the name. It was trademarked in '95. So it was like there's a whole bullshit backstory of it, but. The guy, we almost had to change the name of the company because the guy who owned Tesla Motors wouldn't communicate with us, and so eventually we sent the nicest guy in the company, who's weirdly Martin's best friend, which I don't understand, but Mark Topping, super nice guy.
I like Mark a lot, actually.
Yeah, you can't not like Mark. It's impossible. He's a super nice guy, so. We sent Mark to go sit on the guy's doorstep and not leave until he until he agreed to at least negotiate with us or something. He talked to us, and then we ended up buying the trademark for $75,000.
Good deal.
Yeah.
Was he the one who owned the domain too?
No, that was a whole different nightmare. The domain guy, that took us 10 years to buy that Tesla.com domain. Man, and he is, I think, still like a networking engineer at Juniper. So, yeah, that cost us like $10 million.
Yeah, that was
crazy.
Like the guy just held out.
Yeah.
Was he just sitting on the domain, or was he using it for something?
It was impossible to. No, he wasn't using it for anything.
Just holding the name. It's like Twitter handle Falcon Heavy isn't being used. We're fighting for that one.
Yeah, so man, took us ages to buy the Tesla Economy. But we were gonna have to change the name to be something else. And actually, the lead candidate was Faraday as the name, because Faraday invented the electric motor, and then Tesla perfected the electric motor with the AC induction motor. So if we couldn't do Tesla, we would do Faraday, and then ironically, a competitor was later created called Faraday.
Faraday, yes. A startup.
Yeah.
From China, right?
Yeah. So.
Did you guys have a Faraday logo or anything? Were you that far down the
No.
track?
We didn't really even have a Tesla logo until later, because there was nothing to sell or anything. So, but in the end, the Tesla logo and the Tesla font was done by me working with basically a little firm. That's why the Tesla and SpaceX, there's some similarities between the fonts, and that's because it was done by the same people.
Cool.
Yeah, I spent a lot of time on the Tesla and SpaceX fonts. Get the little things.
That's cool.
You want to eat now?
Yeah, sure.
Excellent.
I think it's all in the kitchen.
All right.
Awesome.
It would be much easier if the world was flat, or if you're in a flat situation. As soon as things are not flat, and you've got the world is like, it has undulations and curves, and then the car can be at any kind of angle, and then if you accelerate or brake, it's actually going to tip a little bit.
Yeah,
you've got sort of pitch and yaw compensation. That's where it gets really tricky.
Yeah, I mean, they're doing just amazing work. It literally just blows my mind every time, like, there's an update. Like, you think it's like, wow, I can't believe it's this good. And then it just gets better.
Like the big one was the faster lane changes. Like as you push the turn signal, it's like immediately. It's really awesome.
That's so satisfying.
Yeah,
And,
love
you know,
that.
I was kind of just like before, I was like, okay, it's not that good, but it feels good because like I can't believe a computer's doing this. Then we got the faster ones, and I was like, oh my god, it was so bad before. Like, you know?
Yeah.
I mean, it'll be able to just do crazy maneuvers, like a high-speed chase, technically, because it's you don't always want to bias the thing to be conservative in the actions that it takes.
Yeah.
But there's quite a significant foundational rewrite in the Tesla Autopilot system that's almost complete. As
Really?
well, yeah.
And what part of the system? Like perception, like planning, or just like?
It's instead of having planning, perception, image recognition all be separate, they're being combined. Yeah.
I don't even understand what that means.
Effectively, like the sort of neural net is absorbing more and more of the problem.
Right.
Beyond simply if you see an image, is this a car or not, or what, you know? It's kind of what do you do from that? 3D labeling is the next big thing, where the car can go through a scene with 8 cameras and kind of paint a path, and then you can label the path in 3D. This is probably 2 or 3 order of magnitude improvement in labeling efficiency and labeling accuracy. You know, 2 or 3 orders of improvement in labeling efficiency and significant improvement in labeling accuracy, as opposed to having to label individual frames from 8 cameras at 36 frames a second. You just drive through the scene, rebuild that scene as a 3D thing with. It's like there might be 1,000 frames that were used to create that scene, and then you can label them all at once.
Is that related to the dojo thing you mentioned at the autonomy day?
No, Dojo is for learning, for training the neural net. That's like when you're trying to build the neural net that you ship into the car, Dojo speeds that up by hardware accelerating it.
Yeah, exactly.
Are you guys, is that up and running yet, or?
No, it might be. We might have the first one at the end of this year, but next year, I think it's very likely next year, maybe this year. But it's essentially meant to absorb massive amounts of video input, and then train against vast amounts of data, so that it can be used in the inference engine in the car. It's just like a human, really. It's like how long does it take you to learn a subject versus do a subject? You know, it's like hard to learn, say, calculus, but once you learned it, then you can, you know, integrate something fast or something. You know, it's like it's really the same basic thing.
Yeah, I mean, that'll just really tighten the feedback loop. Like, at some point, it just gets impossible to catch you guys. I mean, like, the rest of the people haven't even really, like, started, the rest of the auto industry. And, like, the feedback loop is just getting so tight with autopilot now. It's just, like, makes it a lot easier.
I think they will catch up eventually. Or at least they will catch up to where Tesla is now. I don't know. I mean, things like, for example, we're talking about maps and directions and how today, like, computer-based navigation is considered trivial. But, you know, back in '95, it was not trivial.
Right, yeah.
It was considered very hard. And the compute power you had was tiny. So, the code had to be super tight. Couldn't have fluffy code if you're, you know, trying to execute something on like a 386, you know. It was like very, very puny amount of memory and compute. So now but now maps and directions are easy. I think at some point in the future, it might be a decade or something, then autonomy will seem easy.
Yeah, I mean, it'll obviously be commoditized in the long term.
Yes, it will seem easy in 10 years, but there will be a long stretch there where there'll be vast differences between cars. Well, and the auto industry is used to slow rates of improvement, so you know, there's still not really a car yet that matches the original Model S. Maybe you could argue like Taycan
2012.
maybe.
Yeah.
If you look at like the EPA ratings, it literally is just all below.
Yeah. So that was 2012, and it's 2020. Mm-hmm. So it's still like pretty hard to get a car. Let's say there's not a car available at the price of the Model S that has the capabilities of the Model S of 2012.
It's kind of exactly what you were talking about with the Elise, where you're like, oh, we'll just put a battery in the Elise, and that kind of showed you like, okay, we really need a ground-up electric design. Yeah. And the rest of the industry hasn't done that. The sort of founding principles of Tesla were basically completely wrong. So the premise going in is like, it's not going to be that hard. You know, we'll just take the Lotus Elise, it's a, you know, nice lightweight car, and we'll take AC Propulsion's drive unit technology, and we'll put them together, and we'll have an electric car, and it'll be great. This sounds pretty easy. Yeah. Except the AC Propulsion technology could not be industrialized. Like, it was like basically handcrafted electronics with an analog motor controller. Yeah. And so depending if it was hot or cold, your car would respond differently or not at all. And the motors were hand wound. It was just like it was like impossible. You cannot scale this technology. You could have like finicky, individually made, super expensive prototypes, but we ended up using none of the AC propulsion technology. So. It's something that looks cool and works well at an individual prototype level does not necessarily scale. And then like I said, it was like maybe 7% of the parts of the original Roadster were in common with the Lotus Elise. It would have been way easier if we started from a blank slate. It would have been a better car. But I think like the real
test of any given startup is how well does it respond to adversity and adapt and just figure it out. So like most things are just, when they start out, they don't make a lot of sense. But then as long as you adapt quickly, then you can make the company work. If you say like sort of Confinity, doing Palm-Pilot tokens with an infrared port made no sense, but they adapted quickly to online payments. That was key. At X.com was originally going to buy it off way more than it could chew by trying to do all the banking services, and then also focused on payments. It's like, if we do all these banking things, we're going to need a banking license. The banking license is going to slow us down. We're just focused on payments, so we can just get a payment, license from the state, and it's just like $50 or something. You can be a money transmitter, literally. And so you just got to adapt quickly.
You kind of need to be naive, though. If you had known as much about manufacturing, you might not have done it.
Yeah. It would have been difficult to. I guess if you know the outcome's going to be good in the end, sure. It sort of depends on how much foreknowledge do you have about it. Manufacturing is insanely difficult. It's underappreciated in its difficulty.
Yeah, no, that's totally true.
Yeah. Even making the Roadster, which we only like peak made about 600 Roadsters in a year, but call it like 10 a week or something like that. 10 or 12 a week. So, if 2 got made in a day, that was a big day. Tesla's making over 1,000 cars a day now.
What I find amazing is from start to finish, a car is made in 48 hours.
Yeah, depending on what counts, start to finish.
Yeah, it depends. But you can see the rolled aluminum in one section of the factory, and you can see the cars coming out the other end, and it really is astounding. And
Yeah.
cars have been built for a long time, but this is just astounding. It's still, when you don't appreciate when you're driving a car how much goes into the level of detail, the 10,000 parts that come together, the shaping of everything.
10,000 unique parts.
Unique parts.
Wow.
I mean, the pack alone is several thousand cells.
And it all comes together with people that are skilled, but skills are changing as things become a little bit. There's